the squirrels. Just from 10,000 feet, what problem are we trying to solve? If you can imagine an exfiltration box that is inside of a corporate, or not necessarily corporate, but some sort of target site, if you want to abscond with that data wirelessly, there's a lot of standard protocols that might be used. Could just use the existing Wi-Fi network of whatever institution you're dealing with. You may have your own separate sort of Wi-Fi access point. You may use off-the-shelf stuff. Could kind of go down to maybe a Bluetooth option or a LoRa radio or who knows what. You could roll your own protocol. But kind of one of the key things is somebody, monitoring the RF spectrum. They're kind of going to know where to look, right? They're going to say, hey, is there some suspicious Wi-Fi traffic? Is somebody operating on a frequency that we might expect? And so when I say where, I'm talking about a location in the RF spectrum here. And so the goal of this project was really, what if we could come up with some sort of system that allowed for getting the data out using any frequency we wanted, using any data rate we wanted, any modulation scheme we wanted, any type of baseband encoding that we wanted. And some of those words may not be 100% clear to you, but hopefully you can get the idea that what we're dealing with here in this proposal anyway is the exact opposite of a fixed function off-the-shelf system. This is a system that has very odd and variant behavior from the standpoint of somebody hunting it. And even if they do see a spike on excuse me, on a spectrum analyzer or on some kind of SDR equipment, they aren't necessarily going to be able to make sense of it unless they put a lot of effort into reverse engineering a fundamentally different signal every time they see a spike. So this is kind of from a high level what I wanted to implement. And as has probably been hinted at numerous times already, SDR is a great platform for thinking about systems like this. And so for those of you who aren't that familiar with SDR, software-defined radio, and what it is, just at a very high level, you can think of your computer is plugged into some hardware, some programmable radio hardware, and essentially you can code the radio you want. This is a very high-level view. There's some caveats to it, but for the most part, you can build the radio you want in code, or at an even higher level, there's a tool called GNU Radio Companion that allows you to kind of graphically build the radio, which is honestly where most people end up, is that graphical level. Throughout the presentation, you'll see how I dived a level deeper into the code level, and you'll see the advantages to doing that. And hopefully I'll demystify that process to where it's not quite so scary to get into that. So just in general, if you want to build an SDR system, you need some kind of computer and you need some kind of SDR hardware, and that's about it. Now, that computer can be all sorts of things. It could be a laptop, could be a desktop, or could be any other small form factor device that supports the SDR software you're looking at. The Raspberry Pi supports almost everything under the sun, and you'll see that we end up using that here in a minute. But on the SDR side, I can talk if anyone has questions after about, choosing the SDR to work with or whatnot. But for this particular project, and you'll see in the demo visually, but I ended up using a couple of different SDRs. And then the antenna is an obligatory thing. You have to plug in an antenna and the SDR. I'll be able to show you that if you haven't actually seen one of these devices up close, but that's no big deal. An antenna is just a few dollars in most cases. And then a power source. In many cases, you might want this exfil box to be running off a battery, so it doesn't have to be plugged into a wall, and even more conspicuous. And fortunately, things like Raspberry Pis can be run off of all sorts of different battery setups. So let me get into the specifics of what I used, because there are a number of different ways one could have solved this problem, but in my case, well, actually, let me step back and just talk a little bit more about the system. What I did kind of at maybe a 5,000 foot level is I designed a system that has a host that this is going to be sitting outside of the target site in most cases. It could be you sitting in a weird van. It could be a person, or it could be a headless device that's plugged in a few 100 feet outside the target location, but maybe you can control it headlessly. I mean, there's a bunch of different things the host could be, but essentially it's a computer with an SDR hanging off of it. And that computer has some amount of code on it that will transfer to the exfil box inside the target location a set of RF parameters saying, hey, go ahead and reconfigure yourself to use a particular frequency, a particular type of modulation, a particular type of encoding. Go ahead and reconfigure yourself based on what I'm telling you. That exfil box is going to receive that transmission. It's going to say, okay, I'm going to change myself to be a different kind of radio. After it does that, it's then going to use that new set of radio parameters and push that information back out to the host. So you've collected some juicy data. You're just kind of sitting on it as this exfil box, and then eventually the host says, hey, I want it, send it to me this way. And you reconfigure yourself and you send it out that way. The host, of course, knows what that new set of radio configurations are because it just sent them. And so the host is already reconfigured itself and sitting there waiting for the good stuff. And that's kind of at a high level what I built. The one thing that I did do for this demo is I kept the control channel, in other words, this first arrow that pushes out the parameters, I kept that fixed. And that was really just to keep the demo from having more potential risk. And also because this is really a proof of concept design. And if you want to really implement this, it would take a little bit more work in terms of just building in some more error correction and hardening it. And that wasn't something I had the time to do. And so, yeah, I focused on the RF side of this problem, and keeping this control channel fixed meant I didn't have to worry about the host and the exfil becoming permanently out of sync.